Hi, this is Rob. I'm going to show you how to do the exercises that go along with the video lesson, Laws of Exponents. Are you ready? Let's get started. For our first problem, we're told simplify this expression, and we're given 5 to the power of 0. And if you remember from the laws of exponents, one of our laws was x to the power of 0 equals 1. And so x just means any variable or number, and then that raised to the power of 0 equals 1. So no matter what number, it's going to equal 1. So 5 to the power of 0 equals 1. For problem 2, we're told to simplify this expression, and we're given y to the power of 1 equals, and if you remember one of our other laws of exponents, the very first one we learned is x to the power of 1 equals x. So this means that any base, any variable, any number, any base raised to the first power is that same base. It's that same variable or number. So y to the power of 1 equals y. For problem 3, we're told to simplify this expression, and we're given 2 to the power of negative 1. And negative exponents, we have a special law that tells us what to do with negative exponents, and that law is x to the negative n equals 1 over x to the positive n. So this means that a base raised to a negative exponent will be 1 over that same base raised to the positive exponent, the same value of exponent, but positive instead of negative. So that means that this negative 1 will become a positive 1, but it'll be 1 over, and then 2 to the positive 1, and as we learned before, any number raised to the first power is just that same number. So 1 over 2 to the power of 1 equals 1 over 2. And of course, 1 over 2 is 1/2, and so we could also write it as 0.5, getting a little crowded there. But probably this version here, just 1 over 2, is probably the best way of writing the answer, the simplified form of 2 to the negative 1. For problem 4, we're told to rewrite without using the fraction form. So we want to rewrite this where it's the same value, but it's not in fraction form. And this is very similar to the last problem we had, and so we're going to use the same law. Remember, x to the negative n equals 1 over x to the positive n. And these can go either way. They're not just one direction that we can use these in, because these are equal. This here means the same thing as this. So we can go from this to this and vice versa. So we're going to have the same base. We're going to have x, and then instead of positive 3, we're going to have a negative 3. So 1 over x cubed equals x to the negative third power. For problem 5, we're told to simplify this expression, and we're given x squared, and that's in parentheses, and that whole thing raised to the 5th power. And we have a law that tells us what to do with that as well. That's x to the m, that's in parentheses, raised to the n equals x to the m times n. So if we have a base raised to a power, and that whole thing is being raised to another power, then we can just multiply the exponents together, and we can get rid of the parentheses. So we just multiply these two exponents together, so that will be x to the 2 times 5 power, and that's x to the 10th power. For problem 6, we're told to simplify this expression, and we're given x to the a inside parentheses, and all of that raised to the b. And just like our previous problem, we can simplify that. We can get rid of those parentheses by multiplying our exponents. And so even though they're variables, we can still multiply them. We just have to keep both variables. We don't know what number that will be because we don't know what a or b is. And we can show this even a little more simply by not showing the multiplication symbol there, because remember in algebra, multiplication is implied. So we can just write it as x to the ab. For problem 7, we're told to simplify this expression, and we're given a squared times a to the 4th. And we have a law that tells us how to deal with that. you remember, we have x to the m times x to the n equals x to the m plus n. And if you forget these laws, you can figure them out just by thinking about what exponents really mean. Because a squared is the same as a times a, and a to the fourth is the same as a times a times a times a, and both of those are being multiplied together. And so what we have is we have 6 a's being multiplied together, and so that is a to the sixth. And you can get that by using our law here, by just adding these exponents, a to the 2 plus 4, which equals a to the 6, just like this way showed us, but this way is much quicker. For problem 8, we're told to simplify this expression, and we're given a squared times a to the negative 4. And this is just like the one we had before, except we have a negative number this time. So we have a 2 plus, but it's negative 4. So we could have just put 2 minus 4, but that's because they're the same thing, 2 plus negative 4. And so that gives us a, and then 2 minus 4, a plus 2 negative 4, gives us negative 2. So we get a to the negative 2. And then this is what I would consider the simplest version of this answer, but you could also write this as 1 over a squared. They're both correct answers. Which one is simpler isn't completely obvious, but this is the one that I would consider the most simple. For problem 9, we're told to simplify this expression, and we're given x to the 7th over x to the 5th. So remember, we have a law for that, which is x to the m over x to the n equals x to the m minus n. And so this just means that the bases are all the same, but the exponents can be different. And then we just subtract the bottom exponent from the top exponent. So in this case, we subtract 5 from 7. So this would equal x to the 7 minus 5, and 7 minus 5 is 2. So x to the 7th over x to the 5th equals x squared. And if you forget this rule here, you could figure this out by just thinking about what it really means. We have 7 x's being multiplied together. That's what x to the 7th means. And that's over 5 x's being multiplied together. And you can see that they form pairs of common factors that can be canceled out like this, leaving 2 x's on top, 2 x's being multiplied together, and then no x's on the bottom, but that means there's a 1 there because there's always a factor of 1. And so that's x squared over 1, which is x squared, which is what we got from subtracting the exponents. For problem 10, we're asked, can this be simplified? If yes, then simplify it. If no, then explain why. And we're given a fraction again, and we have a squared over b to the 8th. And we need to know if we can simplify it. Can we use the trick we used before to subtract the exponents and simplify this? And unfortunately, we can't, because we have different bases in this case. And we can only use the subtracting the exponent trick if the bases are the same. So the answer is no, because the bases are different. For problem 11, we're told to simplify this expression, and we're given AB inside parentheses cubed. And so we have a law that tells us what we can do when we have 2 numbers being multiplied together, and that quantity is being raised to a power. And that law is xy in parentheses to the m equals x to the m times y to the m. So that means if we have 2 numbers, or 2 variables, being multiplied together, and that whole group is being raised to a power, then we can distribute that exponent to the individual variables or numbers being multiplied together. And so we're going to distribute that 3, the exponent of 3, to both the a and the b. So this will equal a cubed times b cubed. And that is the simplified form of ab, all of that cubed. For problem 12, we're told to simplify this expression, and we're given x over 2y, and that's all in parentheses, and that whole thing is squared. And just like before, where we could distribute an exponent to two variables or numbers being multiplied together, we can also distribute that to a fraction. And our law that showed that was x over y, that whole group to the n, equals x to the n over y to the n. And so we just distribute this 2, the power of 2, to the x and the 2y. So we have x squared over 2y, and then we're going to distribute this 2 to this whole group, to 2y squared. And now we still have parentheses, so we can simplify this further. And we have x squared is already simple on top, and then we distribute this exponent to both the 2 and the y. And so 2 squared is 4, and then y is squared. So x over 2y, that whole group squared, equals x squared over 4y squared.